In this second video on section 7-2, we'll look at finding missing side lengths, okay? And before we do, I want to talk briefly about the different kinds of ratios that we could use and how we could use the scale factor to do this, okay? We've already talked in the first video about corresponding ratios, okay? For example, the fact that 2 over 4 is equal to 5 over 10 is equal to 9 over 18, okay? And all you would need to do is put in the place of one of those lengths, the missing length, for example, x or y or whatever the variable may be, okay? Another ratio you could use and you could look at was, for example, 5 over 2 is equal to 10 over 4. Okay, now that's a kind of a ratio kind of inside or within each figure. Or you could look at 9 over 5 is equal to 18 over 10. Okay, now I call this an internal ratio. I'm not sure if that's the true mathematical name or if there is a true mathematical name, but that's what I think of it as. Okay, so you could use either one of those ratios to find missing side lengths. Okay, one more way that you could do it, which is a pretty common way, is by using the scale factor. Okay, now the scale factor you would get from the corresponding ratio is 1/2. Okay, so any length in this triangle, if I multiplied it by 1/2, I would get the length in this triangle. So I take 18 times 1/2 is 9. 10 times 1/2 is 5. Okay, and similarly, you can either to go from this triangle back to this triangle, you can either multiply by the reciprocal, which in this case is multiplying by 2, or you can take the same scale factor 1/2 and just divide by that scale factor. Okay, so I could take 2, divide by 1/2 and get 4. Okay, now in this, now dividing by a fraction may be kind of confusing to some of you, but that's a way of doing it. Okay, let's look at a problem. These quadrilaterals are similar. Find the values of each variable. Okay, now I'm personally going to use corresponding ratios. I think that's the simplest way to do it. And I'm first going to find x. Okay, now x corresponds with 12. And so I'll set up the proportion x over 12 is equal to, now I will look for a ratio between these two or two corresponding sides that I know. Okay, and I know 6 and 9. Okay, now before I put 6 and 9 up there, let me think really quickly about the ratio that I just wrote, x over 12. I'm relating the smaller side to the bigger side. Okay, so it's important that I keep that consistent. Okay, so with 6 and 9, I will keep the 6 for the smaller polygon to 9, the larger polygon. Okay, and that gives me the ratio of what I need to use. So I will simply solve this proportion. I will cross multiply. X times 9 is 9x. 6 times 12 is 72. Divide both sides by 9, and x is equal to 8. Okay. Similarly, I will find y. Now, y corresponds with 6. Okay. So I will look at the ratio of y over 6. Now, keep in mind the ratio that I just wrote. This ratio now is the bigger over the smaller. Okay, so y over 6 will be equal to, I can use the same ratio that I know, is equal to 9 over 6. Okay, now if you're smart, you can look and say, well, these numbers are the same, and so these numbers must be the same. Okay, so y must be equal to 9. Now, if you want to cross multiply instead and say, you know, y times 6 is 6y, and 9 times 6 is 54, divide both sides by 6, y is equal to 9. Okay, you get the same thing. All right. Now, the last one we'll find is z. And again, I will put z over 3.5. And again, I'm looking at a big over small ratio. So I will use 9 and 6 as a big over small and solve that proportion. Okay, for the sake of time, I won't actually solve that one. Okay, here's a word problem, and there's some word problems in your practice problems. And the question is, the space allowed for the mascot on a school's web page is 120 pixels wide by 90 pixels high. its digital image is 500 pixels wide by 400 pixels high. I changed it so it's a little more interesting and more like the one you have to do. What is the largest image of the mascot that will fit on the web page? Okay, now just looking at the numbers, I don't know if it'll be, too tall this way, if it'll fit better this way, or fit better this way. I'm not sure which of those will work. Okay, so I'm just going to pick one. I'm going to pick the 500. Okay, and find using this ratio, because it has to be in the ratio of 120 to 90. So using the 500 pixels as the length, what height would the picture be? Is it over 400 or is it less than 400? So I will look at 90 over 120. I'm looking using an internal ratio this time, is equal to x. I don't know the height. I'm going to call this length x of what the picture would be over 500. Okay, and I will cross multiply. This gives me 45,000 is equal to 120x. Divide both sides by 120. And x is equal to 375. Okay, so this would fit more like this. Okay, and this actually would be the largest one that you can make. Okay, so the largest one, the answer would be 500 pixels by 375 pixels. Oops. Okay, because the 375 is less than 400. Now let me show you what would happen if by chance you picked the other length to try first. So if I tried 400 first and thought of this length as y, again I'll keep the same ratio the same. 90 over 120, an internal ratio, is equal to, now 400 is now the height, 400 over y, and if I solve this, 90y is equal to a very large number, 48,000 divided by 90, divided by 90, okay, and y is equal to 533.3 repeating. Okay, now hopefully you see that this is larger than this, and therefore it'd be too big. It would be too wide for the space we have for our mascot picture. Okay. The last problem we will do together is another word problem because I think those are more difficult. You want to make a scale drawing of New York City's Empire State Building. Using this scale, 1 inch is equal to 250 feet. Okay, so here's our scale factor, and that relates, the actual drawing, the drawing and the actual Empire State Building. If the building is 1,250 feet tall, how tall should you make the building in your scale drawing? Okay, now I'm going to again set up a proportion. Okay, and the proportion will be 1 inch to 250 feet. Okay, and I'm doing a drawing dimension over the building dimension. Okay, now the actual building will go on the bottom, so it'll be 1,250 feet, and I want to know the height in my drawing. Okay, it's important you have those ratios a match. Okay, and I will cross multiply, and I can kind of forget about the units because it'll work out that this unit will be in inches. You could convert, but it would get really messy if you did. So I'll just kind of forget about the units and say 1,250 is equal to 250x. Divide both sides by 250. Divide by 250. And x is equal to 5, and so the answer is 5 inches. Okay, let me kind of briefly mention before we end that I kind of forgot about the units and said they didn't matter. Okay, and the reason I can do that is because this is feet and this is feet and this is inches, and now my answer that I get will be in inches. Okay, as long as that matches, you can forget about the units. Okay, if they gave me the scale drawing, the actual building in meters, then I would need to convert from meters to feet so that I have these units being the same. Okay, and that's the end of our discussion about similar figures and how to use similar figures and proportions to find missing side lengths.